Hello guys, and welcome back to my new tutorial series on how to make your own AI. Now, I just wanted to start off with a quick overview on what we're going to be going over in this tutorial. So, I have here an EQS testing pawn here, and as you can see here, it's running its own test, its own EQ environment query. So if I open this up, and I can show you, it's running its own custom test here. And what this test is actually doing is if I open up the player score test blueprint that I'm going to be going over how to make today, it's actually calling this interface here and getting this property here, and this works in playtime but not in the editor, unfortunately. But if I was to click play here and come back to jump out here, then change this from to 5, and then back to the pawn, you'll see that it's actually changed the value that it's got here. Now you can use this to filter and score EQS systems and stuff like that. You could use it in entirely different scenarios that you want, but yeah, I think that you guys will probably enjoy this. There's not a lot of information out on how to do this, so that's kind of what sparked me to make this tutorial. You can use this in your behavior trees, or if you just want something quick to do that, or you just want to learn something new, you know. Yeah, stick around and I'll show you how to make this. So, as some of you may have seen on my Reddit recently, I've posted a behavior tree and in that behavior tree I've used the EQS system in Unreal to make some custom tests, and yeah, that's what I'm going to show you how to do today. So I'm just going to load up the Epic Games launcher. I'm just going to close these down real quick down here. These are my references, so I might be referring to them because this is a little tricky. There's not so much documentation on this. I've just had to sort of scrape together how to do this as fast as I can, and yeah. So I've got an AI project here. I'm just going to quickly delete that. So we have a blank canvas here. Project files are on my Patreon as well, so just if you want to view the project right now and just play around with it, the link will be down in the description below. I'm going to go with the third person template, C++ base, no starter content, and I'm just going to put this as AI_project, and that all looks good, so I'm going to create it. So what I'm essentially going to be doing first of all is just doing some project setup and trying to explain how I would set up a project now. Well, I've been using Unreal for quite a few years now, so I would describe myself as quite an advanced user of the engine, and I know how to do quite a lot of stuff. So, but two things that I've recently started doing is separating my code into modules, which I can show you in my main project here, Project Mirror. And I've got all these modules over here. So I've got the air tank module, artificial intelligence, which I'm going to be going over, and you've got all these public and private folders. And the thing that we're going to be going over today is the EQ_player score. Now, if you wanted to, you could just screenshot this or leave it like this, so you guys can just copy and paste the code as you need it. I've got a function library here. It's literally just a log function that just makes it a lot easier for me personally to debug. So I'll leave this open here if you just want the code and leave, but if you wanted to learn a bit more about the engine itself, how to make modules and how to do all this, then stick around and hopefully you'll find it useful. So I'm going to open this in a new window just so I've got this one to refer back to in case I need it, because trust me, this is not as straightforward as I would like. So we've got this new map here. This is in the AI project. Yep. So I'm going to create an EQS testing pawn. Now to do this, just right click, blueprint, pick parent class, expand the all classes here and just type in EQ test, and you should see EQS testing pawn here. I'm just going to put this test pawn. Second thing we're going to need is right click, artificial intelligence, and we actually need a query to test. So I'm just going to put in player score, and there we go. So how does the EQS system work? And I do realise now, saying it out loud, that it's environment query system. It's not supposed to sound like that, but there's a Doctor Who reference to be made there, but I'm going to restrain myself. So we've got the root root query here. If we drag it down, we've got a list of generators. Now these generate what are called items around certain contexts. And if you're completely new to the EQS subject, then I will leave some helpful links down below as well to help you get up to speed. I had to learn all of this through some very useful links as well, all of which will be down in the description. So if we were to example, I'm just going to choose one to demonstrate here. So I'm going to go with the grid one. Let's go for the grid. Now you'll see here it's generating around the query itself. And this is what's called a context. So if we generate around, we can either generate them around the item or the query. Now the query in this instance is going to be the testing pawn. So if we drag out the test pawn here and assign player score thing here, you'll see it's generating these spheres here. These are what are called items. Now if I move this around, then you'll see it moves with it. Now we don't want it to generate balls like this. We want it to generate around certain actors. Actors that so actors. We want it to find different actors. So if we come back here, get rid of the simple grid and just actors of class. Now we want it to search around the query itself, so it's going to be finding different different actors around the query itself. So if we save this and come back to here, you'll find that it's generating these items around the actors in the scene, and some of them are a bit too big to actually see the item. So if we just drag this over here, you'll see, okay, I think that is actually, yeah, it's generating around the origin of each actor. So we don't want that. We want it to generate around, we want the search actor class here to be of a specific actor. So blueprint class, type actor, player score test. I'm just going to drag this out in the scene and edit it. And if you've still got the environment query thing still open, then it should bring it back here. So search actor class here, and we're going to type in player score test here, and now it will only generate these points around that. So something that I might go into in the next tutorial is how to make custom generators, so we can expand on this, but for now this will do. So what we want now is an interface to get the player score at that particular point. And some of you might be wondering, what do I mean by player score? Well, the idea comes from a game called Hello Neighbor. If you're unfamiliar with the game, which some of you might be, is basically a cat and mouse game. You're trying to break into a guy's house and try and find what he's hiding in his basement. Now, one of the main selling points of that game was the AI being able to learn where you've been, and this is my implementation of how to do that. You basically have these actors around the environment that every time the player interacts with, their score goes up, so the AI can kind of see, oh, he's gone to this area quite a bit, it's very likely that he's in this area again now that I've lost sight of him. So that's the idea behind this. Obviously this is a very basic implementation, you can take it much further, and this is the part where I talk about modules for a little bit. So I'm just going to save everything that I've just done, save, close it down, and come back to my IDE. Now, you might be using Visual Studio or something else. I'm using JetBrains Rider. It is paid software, so the process is going to be slightly different. I will leave some links down below about how to do this. Unreal's documentation is very good when it comes to this. It's very easy to follow. With Rider, all you really need to do is click on the source folder, add, and it has Unreal module here for you. So I'm just going to untick both of these because that's not necessary. I'm going to type in AI_module. The module type, you've got all these different types here. So you can have like server only modules, editor, developer. The default is runtime. And the loading phase, this is basically when the module is loaded in. So if you want it to load in before, or you need it to be loaded in before certain areas, it's like if you want it to be loaded after the engine's been initiated, after the splash screens, as early as possible, pre or post default. I'm just leaving it as default because that's what I need. Click OK. And this is what you should see when you load up your modules, H folder. And I'll leave that open there just for a second while I get the other one loaded up. So the CPP folder as well. Why is it giving red? Is it in the build.cs? No, it is not. That's why. Okay, so two things that you need to keep in mind when you're making a module. If you're just making this in the for example, the file explorer, you can just left click here, and what you need to do is delete this and then left click here, just generate the Visual Studio project files again, and you should be good. Private dependency module names, add range, new string array, and this is going to be AI_module, and there we go. That should now, as added here, yep. Yeah, we're all good. So if we just build that now, this should work fine. If your build time is a bit long, then I'd recommend closing Unreal down and then building it, because sometimes the DLLs can expand the build time to an uncomfortable time length. So yeah, it's all good now. So what we'd want in here, we after this is finished building, we're going to open Unreal back up, and it should now have this module registered for when we go to create a new C++ class. Now close all that down because we don't need it. So we've got this now clean, fresh module. What we can do in here as well, it's quite cool, we can actually declare a log category. Be careful because it has to be this macro here for what I'm about to show you to work. Declare _log _category _extern, so log AI. Default verbosity is going to be log, and compile time verbosity, and in the CPP file I'm going to, just down here, I'm going to define log category log AI. There we go. So come back to here, and if we go to tools at the top here, new C++ class, and over here what we want is an in query, and we want so you can do custom generators as well. That doesn't surprise me at all. So we've got environment query test, that's what we want. Go to next here, and over here you should have a drop down, and you should have AI module now, so just click that, type in environment. Is it environment or is it environment query? I can't remember. Let me have a look. Environment query /test. Got ya. environment query slash tests, and this is environment query underscore player score. It's going to be a public. So this is what it should look like when you go to create the class. It could, on my old laptop, it used to take ages to add a new C++ class, like talking like an hour. Luckily that my new PC is a lot quicker at this, but it can still take some time. I've run into issues using live coding, so I'm just going to disable that. And we also want another C++ class. Actually, no, we don't. Not yet. That's the subsystem for the AI director. That's not necessary at the moment. So, come back here. Oh wait, no, we do need another. Sorry, guys. We need an interface as well. So, common class down at the bottom, Unreal interface, and is. I'm going to guess it's game framework slash. Oh, it's just interfaces. Okay. I just like keeping things in line with the Unreal documentation. It's quite nice seeing your classes line up with the Unreal's base classes as well. So I just like matching the folder names. Let's just call this AI underscore interface. It's going to be a public class, AI module, create class. So we're basically done with laying the groundwork here. We just need to implement the interface and then use the interface in the environment query, and then we're pretty much there. If it would compile the code. There we go. Okay, so what we should probably do first of all is make sure that the player score test actually uses the interface we just made. So class settings, inherit interfaces, click add, and we should have AI interface. Now this is just an empty interface, so there shouldn't be any functions over here. Save that, and we can probably close Unreal down again just to just so we don't have to deal with any hot reloading issues that I've had to run into in the past. So what we want here is a float. It's a function to return a float. Get player score, and that's the function. Now to make it an interface function, I've found that the best way to do it is a U function with a blueprint native event rather. Now what this basically tells the compiler is that there is an implementation in C++ and in Blueprint, like it could be either or, and it just makes it a whole lot easier. I'll leave some links for this as well down below. So we don't actually need to implement it in the CPP file, so we can just close that down. This is where things can get a little bit tricky, so yeah, I might be referring to my other class quite frequently here. I'm trying to remember it as best as I can, and there might be some copy and pasting. I'm just pre-warning you. And if any programmers out there thinking that they're not a real programmer because they have to copy and paste code, don't worry about it. Everyone does. I think IBM has a copy of Google that they have locally, just so their programmers have some reassurance that if the main site goes down, they still have access to the internet to help them solve programming problems. Like, don't worry about copy and pasting. I'll do my best to explain the code as well. So first of all is we need a constructor. So it's just the name of the class with some open and close brackets and a semicolon. And the second thing we need is a run test. So it's virtual void run test open bracket f in query instance ampersand query instance close bracket const override. If anyone's wondering why I'm reading this out, it's because in case there's some people who are just listening to what I'm saying rather than watching it. Yeah, so cool thing you can do in Rider is you can just highlight both these functions, right click and generate definitions by declarations, and there we go. Remember that you need to include the class name and double colon before the function name in the definition, otherwise you'll run into some issues when you try to call these. So underneath the include in the CPP file, the second thing that we need is another include environment query items, and we need an actor base or all item types. No, I think actor base would be best there because we're trying to get the item actor to be able to call the interface on it. If it was just a vector, then we'd run into some problems there. So it's what we need to do in the constructor. So the first function at the top is we need to override a protected or public, I don't really know, variable called valid item type. I'm going to make that equal to item type actor base double colon static class. Okay, so first thing that we need to do here is we need to check if the query instance owner is valid. So if new object owner equal to query instance dot get owner, no, not get owner, it's just owner dot get. Wait, no, that's a point. We need to check if this is valid. So that's up here. Then we need to get owner, and then just put a exclamation mark in front of it. If you're new to C++ coding, that essentially means that's basically just a not operation. So we can do this with pointers. Again, if you're not familiar with what pointers are, very brief definition is that it's basically just pointing to a memory address. It's not actually pointed to an object, it's pointed to the address to that object. It's quite a neat little trick in C++ and other languages. And what we can basically do with that is to check if it's pointing to a valid object. This is essentially the same as saying if owner is equal to a null pointer. Basically, if this is null, so if it's null, then we just return. And what we can actually do, another neat trick, is we can actually just make it a one-line if statement. Quite cool. Now this is the next part is probably where I'm going to have to copy and paste it because I cannot remember it for the life of me. So I'm just going to come back here, and as you can see, like, look, it's basically doing the same thing. So if this is the part that I'm going to need to copy and paste. And I'm just going to, so it's float value min dot bind data open bracket owner comma query instance dot query ID close bracket semicolon, and then we're going to make a new local variable min threshold value, and that's going to be equal to the float value min dot get value. Now this is again a the float value min is a variable that's already part of the environment query test class, so we don't just getting that. And we're doing the same with the float value max, and it's just the max threshold value is equal to the float value max dot get value. Now I'm pretty sure the next part is a bit that I've done, so yep. So come down to the bottom, and we're gonna okay, this bit I didn't do. This is again something that Unreal did, and it's the item iterator. I'll leave some resources down below on what this actually is, but as far as I'm aware, this is quite a clever piece of kit from Unreal. It essentially stretches the iteration over a couple of frames, and it does lots of fancy stuff behind the scenes to make sure that this is actually working as it should be. So first things first is we need to actually get the item as an actor. So is that the first thing? Yeah. So we can actually assign a variable inside of an if statement and check if it's valid at the same time. So if actor pointed to an actor and this is going to be equal to query instance dot get item as actor, and the index is that no, just to get item as actor. For fuck's sake, I'm sorry, get item actor, not get item as actor. That was very confusing, I apologize. Query instance and it.get index, and inside this bracket we're going to get the player score. So first of all, we actually need to get a local variable at the top. Player score is equal to 0. And what this essentially does is it's assigning the local variable at the top, and then if the item actor is valid, then it's going to attempt it. So, and down at the bottom here, what we're going to do is set the test score equal to player score. So no matter what, this is going to get assigned, and it depends on both the actor being valid and the player score at that actor. So player score is going to be equal to AI underscore interface. Rider automatically includes headers, so at the top here also going to need to include the interface here, double colon, and get, we actually need to execute player score. What this will do is it will only execute on the actor if there is an implementation on it. So yeah, this is quite useful. So it doesn't depend on the actor actually implementing the interface at all, and I just quite like that. So if we come back to here, and the last thing we need to do is actually set the score itself. So these two, the test purpose and the filter type, are again part of the base class. Player scores here, min threshold and max threshold. As far as I can tell, these two oh yeah, they're just for filtering purposes. So if the player score is below this or above this, then it gets filtered out. Personally, I only use this test to score stuff. I could use it for filtering. Okay, next thing we need to do is actually make sure this is working. So to do that, I'm going to log stuff. So I'm going to put one up here. UE log log AI, not that AI. This is going to be a display. AI module.h. There we go. That'll give that. Okay, so we can't just put a simple f string here with that. That'll return an error. So we need to put in the macro text, and inside there we put the tests, text. So running player score test, and I'm just going to copy and paste this. And I'm just going to put down here owner valid, iterating through actors. and down here I'm just going to put player score on actor. And you might be wondering, how do we actually add how do we how do we actually put in inputs into the logs? So for strings it's percentage sign s, and we have to put a pointer to it. For integers it's d, and we just put the number or the variable to the number that we want. And for floats like this, it's just an f and player score. And I believe that's all we need to do. Okay, so if we build this now, you should be fine. Now, if you're ahead of me here, then you might be trying to drag the testing pawn in the scene itself and trying to get it to work and all that other stuff. And well, it only works during runtime because the module's only active during runtime. I think that's how it works. Could be something else, but I'm fairly sure that's the reason. You could experiment with that, but I'm actually perfectly happy with how it's turned out. So interface calls, I'm going to drag this out to a variable. It's going to call this player score, make it public so we can edit it in the editor, save all that stuff. Go back to here, I'm going to put that to 5, and if we drag this around, then you'll see nothing, because we actually haven't added the test to the thing. Player score, there we go, save this, back out here, and you'll see that it's iterating, it's running the player score test, iterating through actors, and the player score on this is 0. If we click on this, okay, I can't click on that player score test, you might see that it's 5, but if we to simulate it, and then go on to the test pawn, then you'll see that it's actually gotten the right player score here, even if we drag it around again. And I'm pretty sure if we change this and then go back to here, yeah, if I was to play this and then detach it, then player score, change this, then it updates it itself at runtime. Yeah, that's how you make your own environment query test. I hope you guys found this useful. If you did, please consider subscribing and checking out my Patreon. All those details should be down below. Yeah, hope you guys found this useful. I'll see you guys in the next episode.